just like arithmetic sequences that we talked about earlier in the year, there's recursive definitions and there's explicit definitions. The explicit definition is the way more useful one because you get one formula and you can find any term in the sequence. So we're going to talk about in this example is converting between the recursive definition and the explicit definition. So first part of the example, when you're given the recursive definition, what is the explicit definition? How do we get to the explicit definition? So here you're given that 5 is the first term, and then 1/2 is the common ratio. All right, so what we're going to do is, show a couple terms here. The first term is 5. The second term is 5 times 1/2. The third term is the second term times 1/2, which is 5 times 1/2 times 1/2. In other words, it's 5 times 1/2 squared. The fourth term ends up being 5 times 1/2 cubed. So the pattern there is the exponent is 1 less than the term you're looking for, right? When the exponent is 3, it's the fourth term. When the exponent is 2, it's the third term. So what we can do is write a formula that covers any term in the sequence where the exponent is n minus 1. So if you wanted the 6th term, the exponent would be 5. If you wanted the 10th term, the exponent would be 9, for instance. So the general explicit definition for any term in the sequence is the first term times the common ratio raised to an exponent that's 1 less than the term you're looking for. Part B, we're going to go the opposite direction. So here's an explicit definition. We're going to go back to a recursive definition. Well, in that explicit definition, you have the first term and you have the common ratio, and that's all you need. So the first term is 3. The common ratio is 2. So the first term is, in the recursive definition, the first term is 3. The second, any other term in the sequence is the common ratio of 2 multiplied by the previous term. All right, you have 2 examples to try here, going in both directions. So pause it, give those a try, and then come back and check. For part A, the recursive definition is given. The explicit definition is a sub n is equal to 12 times 1/3 raised to the power of n minus 1. In part B, the explicit definition is given, and you've got the first term is 6, and then every other term after that is found by multiplying the preceding term by the common ratio of 1.2. All right, let's look at example 3.